All right, hello and welcome. So if you're gearing up for GCSE higher tier maths, you know that mensuration can feel like this huge mountain of formulas to remember. But what if we looked at it a different way? Instead of a long list of facts, think of it as a super powerful toolkit. In this explainer, we're going to build that toolkit together so you can walk into that exam ready to tackle any problem they throw at you. Look, I get it. You might be thinking, there are just so many formulas. You've got area, volume, circles, triangles. It's easy to feel a little bit overwhelmed. But trust me on this, there is a real logic to it all. We're going to break it down so you know exactly which tool to grab for which job. No more guesswork.
Okay, so here's our game plan. We're going to start with the absolute foundations, 2D area and perimeter. Then we'll get into the world of circles. After that, we're jumping into the third dimension with 3D shapes. Then we'll build the ultimate triangle toolkit, and this is a massive one for the higher tier. And finally, we'll see how to scale shapes up and down and pull everything together for those tricky exam questions.
Right, first things first, we have to start with the basics. You know, every single complex shape, every tough problem you're going to face is built on a really solid understanding of simple 2D area. If you can master this foundation, everything else becomes so much easier down the line.
Here are the non-negotiables. You absolutely have to know these cold. The area of a triangle, a parallelogram, and a trapezium. And a quick heads up on the parallelogram. Remember, it's the perpendicular height. That's the one at a right angle to the base, not the slanted side. That's a classic trip-up. These are your bread and butter, the building blocks for pretty much everything else.
So, with our 2D foundations in place, let's talk about a very special shape, the circle. Circles kind of play by their own rules, and they're super important because they pop up all the time as parts of 3D shapes, you know, like cones and cylinders.
Okay, these two formulas are absolutely fundamental. The circumference, that's the distance all the way around the outside, and the area, which is all the space inside. And just a quick reminder, because it's an easy mistake to make under pressure, R is the radius, from the center to the edge, and D is the diameter, which is all the way across. Don't mix them up.
Now, here's the cool part. To find the length of an arc or the area of a sector, you know, a slice of the circle, you don't really need a new formula to memorize. All you do is figure out what fraction of the whole circle you have. Just put the angle over 360. Then you just multiply that fraction by the full circumference if you want the arc length, or by the full area if you want the sector area. It's pure logic.
All right, time to add a dimension. We're moving from flat 2D shapes to solid 3D ones. And here, we're focused on two main things. Volume, which is basically the amount of space a shape takes up, and surface area, which is the total area of all its outside faces.
So, here are your key volume formulas. Now, the volume of any prism, and that's a shape with the same flat face running all the way through it, like a cylinder or even a Toblerone box, is just the area of that face multiplied by its length. And here's a massive exam tip. The formulas for the sphere and the cone, they're given to you in the exam. You don't have to memorize them, but you absolutely have to know how and when to use them.
Surface area can sound a bit tricky, but the idea is actually really simple. Just find the area of every single face of the shape and add them all together. A cone is a perfect example of this. You've got the circular base. We already know its area is pi r squared, and you just add that to the area of the curved part, which is pi rl. See? You're just combining simple bits you already know.
Okay, deep breath. This is a huge topic for the higher tier, triangles. You've got a whole bunch of tools at your disposal, but the absolute key to smashing these questions is knowing exactly which tool to pick for the job. So let's make that decision process crystal clear.
This is it. This is the first and most important question you have to ask yourself every single time you see a triangle problem. Your answer to this one question immediately cuts your choices in half and points you exactly where you need to go. So, is there a little square in the corner?
If the answer is yes, it's a right-angled triangle, then you have two amazing tools. Is the question only about the lengths of the sides? No angles involved at all? That's a job for Pythagoras. The second an angle gets involved, either one you know or one you need to find, you have to switch to trigonometry. That means SOHCAHTOA. It's that clear a choice.
Now, if the answer is no, it's not right-angled, you reach for your more advanced toolkit. But which one? Well, look for a matching pair. That's a side and the angle directly opposite it. If you have a full matching pair, you're going to use the sine rule. If you don't have a pair, like if you have two sides and the angle squeezed between them, or maybe you just have all three sides, then it has to be the cosine rule.
And the final tool in our triangle toolkit is this special area rule. Now, this is not half base times height.
You use this one when you know two sides and the angle that's tucked right in between them. Notice that? It's the same setup you need for the cosine rule, two sides and the angle between them. That's a nice little link to help you remember.
Let's switch gears a bit and talk about what happens when we make a shape bigger or smaller. This whole idea is called similarity. And here's the thing, when we scale a shape up, its lengths, area, and volume don't all change in the same way. There's a really specific and actually quite simple set of rules for this.
So let's start with the basics. We'll call the length scale factor K. So if you make all the lengths of a shape twice as long, K is simply 2. Easy enough, right?
But here's where it gets interesting. Area is a 2D measurement, right? It has length times width. So its scale factor isn't just K, it's K squared. That means if you double the lengths, the area gets 2 squared, or 4 times bigger.
And that exact same logic carries on to volume. Volume is a 3D measure, length, width, and height, so it scales by K cubed. If you double the lengths, the volume becomes 2 cubed, or 8 times bigger. Understanding this K squared, K cubed relationship is an absolute game changer.
Okay, so we've built our toolkit. We've got tools for 2D shapes, 3D shapes, and literally any triangle they can throw at us. The final step, the final challenge, is learning how to combine them. Because the toughest exam questions love to give you these complex composite shapes made of several simple ones all stuck together. This right here is the most important thing to remember. When you see a weird, complicated-looking shape, don't panic. It's just a puzzle. It's probably a cone on top of a cylinder, or maybe a hemisphere stuck to a cube. Your job isn't to find some new, scary formula. It's just to spot the familiar shapes inside it and use the tools you already have. So there you have it, your complete mensuration toolkit all ready to go. The power is literally in your hands now. When you're in that exam and you see a problem, just pause for a second. Look at the shape, think about the information you have, and ask yourself, what's the right tool for this job? What's my first step?